Start recording? We good?
It's doing the circle.
It's doing the circle.
There we go.
Are we good?
Okay.
All right, yeah, we're good. All right. So there were a couple of things that today's going to be a hodgepodge lecture, and my apologies, but we seem to be piecing a lot of things together. Overall, people did pretty well on their game pitch. I know it was a really short amount of time, but I was mostly impressed. If you look at your grade, several people made above 100%, which was pretty awesome, because I was impressed with what it is that you did. You met the criteria. You listed a one-sentence description. You had the assets in place, all of that kind of stuff. Now you have to worry about implementing this, right? And so for some folks, I put in some implementation details or approaches that I would recommend that you take. If you have an implementation problem, what should you do?
Google.
Don't cry. Yeah, okay, so Google is an option, right? Several different things that you can do there, but you can come into my office and you say, I have no idea how I'm going to pull off this lighting technique or this whatever it is that's in your game, or how to even build a platform or something like that. Please come into my office, or at least send me an email and say, can you give me some pointers on where I can begin? Because you're not alone. There are a lot of people who are making fighting kind of simulations and worry about collision detection and things like that. For several of you, I put in that you have multiple ways that you can do collision detection. What's the easiest way to do collision detection? It's actually easier than rectangles. What's an easier way to do collision detection?
Radius.
Straight distance, right? So you should know how to calculate distance. If given xy and xy over here, you should be able to take the square root of. Right? Everybody's cool with that? I'm not going to insult your intelligence, but you get it, right? That's the easiest way. Is that going to work for your fighting Mortal Kombat simulation that you're going to build?
No. Very nicely.
If fighting is the thing that you're going to be doing primarily and you throw a punch and you're not close and it still hits, they might get upset, right? So it depends on the quality of that. Next easiest collision detection algorithm is what?
Rectangles.
Rectangles, right? What's the problem with rectangles?
Sometimes the sprite doesn't fill up the whole rectangle.
Look at the situation. We're going to be talking about animated sprites, but you can assume that if I'm in this Mortal Kombat situation and I'm standing like this, how big is my collision box? It's about the width.
Sort of dead space where you are actually not.
Where you're not is the problem. Exactly. So if I'm standing like this, you can imagine that I have a really thin collision box, right? Now I go and I punch. And let's say I have an obnoxious, I'm not really a fighter, right? But you can see if I do this really kind of far thing, now how big is the collision? The collision box is much larger. So how are you going to deal with that? You could have collision boxes. You could also say that if I'm in this state, then you could move and have a fist collision box, or you could have a body collision box or something like that. Believe it or not, it even works in 3D. When you have these 3D kind of fighting things, they don't do per vertex collision detection. They'll actually have bounding boxes around the fist and around the head, around the body to determine those kinds of things. All right, so be clever with that. If you want to, there's an option where you can do per pixel collision detection. Has anybody tried that?
Yes.
I have not yet done it, but it does work, right? And it is per pixel. So if you wanted to and you had these animated sprites fighting and everything, you could get it down to the pixel, and I believe the runtime is pretty good, right?
It's about the same as just using the distance or any of the other ones.
And there are tutorials that are out there. I have not yet done it. That's a great question. I'll probably do one just to say that I've done it. But realize there's a lot of different things for collision. Almost every game is going to have some kind of collision in it, and that's why we're bringing this topic up, right? Whether it's a platformer, you collide with a platform, any of that kind of stuff, collision is important. All right, any questions about that? Hearing none. You guys are just saying, hurry up and finish. All right. So I have Andrew, you already went. Let's see, removing list from particles. We need to talk about that. Animate sprites. Okay, so let's just get into it. Yes? Where are the 3D X and A tutorials? I can find the link for that. If it's not under resources, there's a great, I thought I had it. There's a great tutorial. Is it Reamers? I think is the person that set all that stuff up. They have 2D and 3D tutorials. If you want, go ahead and look at the assignment, and you can see that doing 3D is not terribly difficult. In fact, hold on, let's see. Resources, no, I'm sorry, schedule. Let's get this guy out of the way. Let's go down here to the 3D graphics assignment. R.B. Whitaker's site right here. So if you want to go and just to kind of quickly look through this, where is it? 3D tutorials. By the end of this, Basic effect lighting, let's just look at it. I think they have a little ship that moves around. This is a 3D ship, and you can rotate it and spin it around actually in 3D space. You have to set up a camera and things like that, but it's not terribly difficult to do. Are you still going to do 3D? Good luck. All right, all right. But he's doing non-Unity 3D stuff, right? Good luck. Good luck. No, it's not terribly difficult, but I'm not going to expect that it's going to be way up here. If you get stuff moving around and everything, then things will be good. Okay. So let's go back. Here we go. Today we're going to talk about 2D sprite animations. So if you've noticed the way that I've laid out these assignments, the first one here is particle assignment. The next one is animated sprite assignment. Then look down here, demo of project. And I know what you're saying. What are you talking about, demo of project? Everybody freaks out on this. We've had a great discussion about this. I am not expecting anything to be even remotely pretty for this demo. Why do I have this demo right here? Because you guys are procrastinators. I learned that lesson as a teacher, and I saw it. Everybody tries to do this big bang at the very end of the class, and it turns out to be an awful kind of project. So what I'm going to do is, for this first demo here, demo of term project, I'm actually going to move the mathematics of gaming up, talk about that, and have 2 times where we sit down and we look at each other's games. How long did it take us to go through just the pitches? Now imagine if you have 2 minutes to demo your game and say, here's the state that it's in. That's what we're going to do. What are the things that you should be working on for your demo? The absolute most basic things that your game has to do. And we're going to talk about the mechanics of the game, right? What it is that you can do. If you have a platformer, which several of you do, what should be in place? Moving, right? So let's go back to the basics. Cornflower blue background. You don't even have to change the background color. What else? Movement, gravity, jumping, collision. Yeah, it would be nice if you could actually land on a platform. That's it. That's all that I want. Say, look, I've got a character that's there. It's not even an animated character, but I can make this box or circle or something land on a platform. Why is that such a big deal? Because it's the fundamental thing that your game is going to be based on. Okay? What other kind of games are there? Fighting games. What should you do? That'd be kind of cool. If you could go up to something like that, you have 2 opposing things, and you press the space bar, and then it says, hey, a collision was detected. You see, so we're talking about minimal kinds of things, but you should be able to build from that and then finish it out to be your final project. Notice the order that we have these. Particle assignment. First one, why? If you do this correctly, you should be able to wrap all of your particle stuff into a class called explosion. And guess what? Very cool. No, I can't do that. How many people can? No, I'm not going to ask. I can hear this. If you did this correctly, you'd be able to have stop. You'd be able to have a lot of different explosions in your game, or smoke, or any of this kind of stuff. So think about why I put that there. Next thing, animated sprite. I think this is required in your final game, right? Why? Because ships are animated, characters are animated. You'll have an animated class if you design this thing correctly that you can then move around on the screen. So everybody get it, right? So we're trying to build it up so that you can integrate your actual assignments and put it into your final project. Yes?
The animations are bone structures okay for 2D?
Ooh. You're talking about the IKs? Inverse kinematics?
Yeah.
Are you sure you want to get into that? Notice that inverse kinematics is down here. Because a lot of times people don't like working with inverse. It's not that it's terribly difficult, but it's not an easy assignment either, right? The heavier assignments are towards the bottom. Other things that you might want to look into if you want to get into it early, flocking, right? This is the intelligent crowds and everything else, the enemies that swarm towards you. 3D graphics, you can probably skip over that unless you're doing 3D, like Chad and his group. And then we have a lot of milestones. So I purposely put in a lot of project time here so that you guys could work on this. This is a very applied kind of class, unlike a lot of the computer science classes or gaming classes that you may have taken. Okay? So does that make sense the way I've structured the class? We're good. All right.
If we're using Unity, how are we going to sort of translate the lessons?
You're not. You know why? Because what do you do in Unity if you want a particle system? You drag a particle system over. But they still, it's the same thing. It's just it's a 3D implementation versus 2D. Okay, so that's good. Now let's talk about 2D sprite animations. And so let's take a step back. What is a sprite? It's just a picture, right? So when we have an animated sprite, gives the appearance that we have an alive kind of thing that goes on. All it is a series of images that are successively played that give the appearance of animation, right? Everybody's probably seen Bambi or some Pixar movie or something like that. How does that work? It's frames of animation, right? So it's one still image, and then you have another still image, and it takes a really long time to make those images. If we look at how to do that in 2D, right? Does anybody know? Well, it says it right there. Yes, it's okay. I was trying to cover it so you couldn't see it, but yeah, Prince of Persia was a classic kind of game back in the early '90s, and so here is the what did you say? Quaffing? I hate saying drinking. Why does it say quaff a potion or quaff?
Wow.
I just read it. I was like, that's stupid. Why don't they just say drink the potion? So quaffing the potion there. We need to talk about this, though. I think you can see the animation that's there, right? No problem. Compare that with the animated sprite sheet that I've given you in the assignment, and you'll see that there are pretty significant differences. Now, if you haven't seen that yet, take a step back, go to animated sprite, and here's the animated sprite sheet that I've given you for the assignment. You're supposed to create this little animated character. Looks like this, right? How is this sprite sheet different than this one?
It's got multiple actions.
There are a couple of very subtle things. So yeah, first thing that's noticeable is this is a one-dimensional kind of thing, right? We just have one animation that's on the screen. Anything else? The spacing is different, and this is huge because I know a lot of you, after you do this animated thing, you're going to have a little animated character. What's the first thing you're going to want to do?
Use the same numbers.
Customize it, right? Oh, wouldn't it be cool if I could create my own little character? And then you're going to have all this kind of stuff. What's the problem with that?
It's incredibly hard.
It is incredibly hard to do. In fact, I had to cheat in mine. I had to render it in Maya. Do you know some of the difficulties in creating your own sprite sheets? Yeah. Keeping the character in the same relative position is a real nightmare. Okay, so if you look at the sheet that I've given you, it's different in a couple different ways. This one here, the image width here is not fixed. Notice that this first little image right here is a really wide kind of picture as opposed to this one where he's standing straight up. Why is that so problematic?
You have to change
You have to figure out where in this one image to pull the next frame of animation, and that's going to be changing every frame. That sucks, right? So if we go back and you look at the one that I've given you, I've tried to make it a little bit easier in the sense that all of these things are either 50 pixels wide or 100 pixels wide. I think I had to cut it down to 50 because there's a maximum texture size in XMA of some number or something like that. So here you can see that all of these things are 50 pixels wide. Why is that cool for us? Super easy, because all I have to do is have a frame counter, right? That's something that would be inside my player class to tell me which column I'm in inside this sprite sheet. Okay, so here's frame counter 1, frame counter 2, and I move over and I move over, right? How much am I moving over each time? 50. So what would that be? I just multiply the frame counter by 50, and then I know where at least the X, the column, starts there for my animated sprite sheet. Yes? Now, you said that I had several different states here, which is true. Here's the idle state, the walk state, the jump state, all this kind of stuff. How am I going to represent that? How am I going to use
rows?
Well, I don't necessarily need an array. Somebody said that. It makes sense, right? Because we're kind of working with something.
You set it as an animated state. So when he's walking, you say animated state 2, it goes down to 2.
You have a state variable is what you're getting at, right? So what's the first thing? State. In fact, I would have all of these things as constant. Idle is the value 0. Walking is the value 1. And all I have to do is to change the state value. And all of a sudden, it's going to bump me down into a different row. What do I multiply by again? 50. And so you can see if I know the frame counter and I also know the state that I'm in, I know exactly where inside this one image that I can extract out that part of the image. Is everybody with me? So they're not hard to do. What's the hardest part about this?
Integrating the jumping.
The jumping is a nightmare. Work on the jumping last, right? Because you've got to get all of this kind of stuff. We can talk about jumping in just a second. What else is difficult? How fast does update get called? The game folks know this, right? Update is called 60 times per second. How many frames of animation do we have here?
12.
Well, it's 24, actually, I think. Well, count them. It's pretty sure it's 24. So this animation should play in 1 second. So in other words, if you were to count out 1 second, 1 second, 1 second, it should hit on this frame every single time. How are we going to do that? If the update's being called 60 times per second, how do I get something that's 24 frames per second? Okay, let me show you a little bit of code, and I'll bring it up here. The powerful, let's see, ooh, here we go, Notepad. The all-powerful, yes. Okay, so imagine that we have void update, and one of the things that update takes in is a variable called game time. And you guys can help me out. I can't remember the exact syntax, but it doesn't matter. I want you to get the concept. Okay? So update has a game time variable that comes into it that has all sorts of useful information in it. The first thing to note is that if I were to type game time, which is the variable dot, and I think it's elapsed what? Elapsed time or something like that. It doesn't really matter. There's an elapsed something there that tells you the amount of time that has occurred since the last time update was called. Let me say that again. When I say game time dot elapsed time, it tells me the amount of time that has occurred since the last time update was called. So what should we expect the elapsed time to be?
A small number.
A small number. Be specific.
Double.
1/60th of a second. Now, how often should we update our frame counter for our animated sprite? 24 times, or 1/24th of a second. So let me show you some code here that's going to help out. How am I going to, if I were to do something like this, in fact, I'll just comment this even though it doesn't have syntax. There we go. And I'll put the semicolon, right? If I were to just say, fine, frame counter plus plus, how fast is my animation going to run? 60 frames a second. I don't want that. In other words, your character is going to be this kind of caffeinated person like me, right? You don't want that. So what am I going to do? I'm going to say, I'm going to use this elapsed time and have a variable that's a float. In fact, I'll put it up here. Float sum, and I'll set it to be 0.0f. Okay? Now, what I'm going to do is aggregate time. Every time update is called, I want to figure out how much time has passed since the last time and add it into this sum variable. So what's going to happen, it's going to go 1/60th of a second, and then sum is going to be 2/60ths of a second. And eventually, how do I know when to update the frame counter?
When sum is 1/24th of a second.
When sum exceeds 1/24th of a second. So what I could do is have a float threshold or something like that. Gets, can I just do this? 1/24th. It looks good. What's the problem, CS folks?
Yes, that's the,
What's 1 divided by 24? 0. You didn't know that, did you? But it is. All right, so don't forget that. Well, how do I solve this problem? Yeah, you can just put 0.0f or something like that, right? So there you go. You've got something like that. Okay, good. Now that we have the threshold established based off of what our artist gave us, what am I going to do?
If
An if statement. If what?
if sum is greater than or equal to
If the sum is greater than the threshold, then it's time to increment that. You with me? Now there's a nasty thing that if I left it this way, what's going to happen?
it will always update.
It's only going to do one frame, right? Because the sum is always going to be greater. Or wait, you know what? It's going to do one frame, and then it's going to do 60 frames a second. I have to reset it, right? So your first suggestion would be, hey, why don't we do something,
Sum equals 0.
yeah, like this? Ooh, yeah, there we go. In fact, I think I have, can I say 0f or do I have to put 0.0? I can't remember. It doesn't matter. Is this a good idea?
No.
No. It has the right idea, right? You know that you want to set it back so that you can aggregate more time and everything else, but this is not the correct way to do it. Why not? It doesn't exactly update it. And what do we mean by that? You're losing little bits of precision each time. So you can imagine if I wanted the frame every second for it to be in that first column, if I do something like this, you're going to lose all of the precision that's been built up over time. So for example, if, let me we don't have a marker, do we? Yeah, we do. If, for example, let's say that our threshold is equal to 0.1, so we have 10 frames a second. Is everybody with me?
Okay.
Let's say that inside of update, we have this game time that comes in, okay? And the elapsed time is 0.9. Is everybody with me? Have we exceeded our threshold?
No.
Now let's review. Okay? The threshold is 0.1. The elapsed time is 0.9. What happens? It doesn't update. So what do? We say that sum is now equal to that, right? So we add this thing into the sum. So right now sum is 0.09. We did not increment the frame counter. Next time update is called, another 0.9 occurs.
So
Now what's going to happen?
Now
It'll
it is, but
updates instead of
Okay, so we update it to 0.18. We know that it's time to increment our frame counter, yes? Okay, so we increment the frame counter. The new value goes to what, 0?
you
So it's gonna
subtract
have
the
that
threshold.
first
What happened to that 0.8?
loss of the abyss.
It is lost to the abyss. And you're going to find out that you start to get really jerky kind of animations. You don't want that, okay? What am I supposed to do instead?
Subtract the threshold.
Subtract the threshold. A lot of people forget to do that. I will notice it if you don't do that in your assignment. I will notice it if you're not running at 60 frames per second. I mean, at 24 frames per second. I see people turn this thing in all the time, and the little characters just going all over the place. And they said, "I did it." Well, you did it wrong. Okay, so does that help you? The last thing, if you look inside the assignment, where is it? Right here. I give you a little bit of code, or at least I thought I did. Or maybe it is here inside of the sprite animations. Yes. So if you look, there are a couple of different ways that you can call draw. And this is the key to being able to work with animated sprites. In this second version right here, sprite batch.draw, notice that you pass it a lecture2. This is the entire sprite sheet, right? All 24 by 4 images that are there. Right here. The next one is a vector2 position, but the important one is this rectangle source. What is that? It's we're pulling out, we're extracting only a sub-image from the main image right there. And so this rectangle is going inside, it should be a 50 by 50 square that you're pulling out of this, right? So it's x over y down, whatever you've calculated, and then 50 big, 50 wide. Also notice that the position is not going to be another rectangle, it's actually going to be a vector2. All right, so you're going to have to play around with this. It's not a terribly difficult assignment, but it's also one that's non-trivial. So I expect that everybody's going to have these fantastic animated sprite sheets inside your games. And if you're stuck, there is hope. And I'm not responsible for what you're about to see. Images.google.com. Wait, I just typed in A.
Amanda Bynes.
Amanda Bynes? No, sprite sheet. And if you look, there are tons of them that are out there. Now, based off of that, it doesn't matter which one of these things we pull up. Would you want to work with this?
Yes. Is that a beaver?
I don't know what that is. Let's try. How about this? This looks pretty cool.
No.
It's missing a spot.
Yeah.
Would you want to work with it?
No, it's not in mine. It's so random.
I want you to be able to look at sprite sheets and say, heck no, I'm not going to work with that. Where's like a really nasty one?
That one.
Let's see. Hold on. Give me 1 second. I want to show you what a bad one would be. That one would kind of suck, but it's still not as bad. Oh, come on. Hey, there's Mega Man.
I like Google terrible spreadsheets.
Because I'm really afraid of what I'd see. My point is, I know that there's a couple where they try to utilize or most efficiently use the space that was in the sprite sheet. And I'm recommending totally against that, right? Assume that we have an infinite amount of texture space that we can use, but they have it where, like, imagine that they're punching up in the air for like some victory thing. It would be in between the feet of another character, right? So when you get into those situations, what can you do? You fire the artist and you say, yeah, because you're not going to deal with that. You cannot go in there and start piecing all of that stuff together. Or some of you have those skills. That is not your job. If somebody sends you some garbage like that, you send it straight back and you say, I'm not going to work with this, right? Artists have their role, and a lot of times we have to educate them from the programmer's expectations, and then they can fix it. Okay, so that is animated sprites. Are there questions about that? Do you think you know where to start? Yeah, go ahead. It can be in PS Vita. Well, the demo that I made here, I believe, is just an executable. Let me...
That way we can't like look into the code.
Yeah, I'm not going to give you the code and say, hey, please don't cheat. Let's see if I can just run it straight. I doubt I can. Yeah, no, yeah, let's kind of back up. Let me show you this real quick, just to make sure everybody's cool with it.
What?
Let's see, hold on.
One me.
Hey, there we go.
Nope.
Wait.
Nope.
Okay. You can run it on your own time.
Oh, wait.
Okay, I'm gonna kill that. I'm afraid of what damage it could do.
Let's get you changed to work.
I hope so. Audio?
Still being recorded.
Yeah. Okay, I think we're still good. Let's get rid of that.
Oh, can't.
Okay.
That's there forever.
All right. To show you some other examples of some more famous ones, this is really small, but here you go. You guys should recognize this and appreciate it for what it's worth. You think about it, they can take this one texture and build an entire game off of it, right? And if you look, I think everything's there. There's no enemies. I don't think any of the enemies are there, but you get the general idea. If you have a good sprite sheet, you can build entire games off of that. I think I also, Legend of Zelda. If you're into the Legend of Zelda series, this is my favorite series. You can see that there are sprite sheets. These are good because they are at least spaced out correctly. And then if you look in some of my old labs from XNA, I've cleaned some of these things up where it doesn't have the weapons on the character, so you could use those things if you wanted to do some Zelda-like kind of animations. Right? It's not as fancy as the Pipe Boy, but it still is pretty good. Okay, and then we're going to skip level editing right now because we don't have to talk about that. It'll make more sense when we get into the 3D. Okay. So the next thing is the assignment, the reading assignment. How many people did it? You just got...
Did we read the book?
What? There's a book? Yes. Did you read the book? Yes. Okay. It's much heavier than this. It's deceptive, right? So notice that I don't have a lot of notes past this point. I'm assuming that you're going to read. The first couple of weeks, people are having difficulty finding the book, half.com and all that kind of stuff. So I have the notes here for you. Ah, good old Jeff. He comes in handy sometimes. Okay, so what did this section talk about? It talked about a lot of the data structures that you should have already seen, barring a couple of things, okay? Most people are already comfortable with arrays and linked lists and things like that. You're going to be using those extensively in this class to build a game, of course. What's the difference between an array and linked list, just to make sure everybody knows? Arrays are fixed length. That's a bad thing, right? Not always. Let's talk about some things that employers may ask you about arrays. Okay? We say that arrays are fixed, which is true, but we also know that arrays are quote-unquote fast. Is that true?
Yes. They're fast access.
Fast access, specifically, okay? It depends on how you use these things. Why are they fast access? Okay, watch this. You guys have all gone through data structures. You should know pointer arithmetic by the time you've made it in this class. Yes? Data structures?
No.
Wait. Maybe I should draw this out. I'll try to put it up here, and my apologies ahead of time. All right. Whoa. There you go. So here's an array.
You can use the pen.
Can I use the pen now? I don't know if this is going to work.
They calibrated before. We'll use that as a
Oh, it's not plugged in?
It should be.
Wait. Why can I not draw? Can I do this?
Yep.
Yes. All right. So here's an array. It doesn't really matter what it looks like. There you go. That's good enough. It's a slanted array, something like that. But why is this important? We say that arrays are fast, but that's not really true. The benefit of working with arrays is that they are contiguous in memory. What do I mean by contiguous? They're all stuck next to each other, and that's the reason that we have fast access, because we can calculate exactly where we're supposed to be. No. I just want to write. How do I write? Pencil. There you go. Is that good enough? Oh, yeah. All right. Okay. So let's assume that this array starts. Let's assume that this array starts at memory location 1000. Right? How do I access the first element here? 0. No, the first element. 0.
Just the name of the array.
Not at 0, but yeah, we calculate 1000. Yes, it is slot 0. You ever wonder why everything is 0 based in computer science? Because of this. Right? Because to do the calculations now, if I want to go to the first slot, which is slot 0, how do I calculate that? 1000 plus 0. Okay, great. Well, how do I get to the, let's see, there's the first, that's, okay. There's the number 2, right? So we can go on, how do I get to the third slot? 1000 plus 2. Is this true? Not exactly. Why is it not true? What's inside the array? Okay, if it's a float, if it's a word or something like that, okay, fine. What if it's a dog?
We have to figure out how big a dog is.
We have to figure out how big a dog is, right? And so you should have operators like, this is really awful, the size of a dog. That comes out to a certain number of bytes, right? So if that's the case, how do I calculate where the third dog is? 1000 is our starting point plus 2 times the size of the dog. Do you see how all of this stuff makes sense now? So if you look at it from that level, then it's really easy to calculate where these things are, and that's why arrays are fast access. So everybody get that? Would that show up in a job interview?
Yeah. Maybe.
Hopefully. Has anybody had something like this show up in a job interview? Yes, you have. Okay. There you go. All right. So that is, those are arrays. I think everybody's pretty comfortable with that. What about linked lists? Why do we like those? They're dynamic, right? What's the problem with linked lists?
Scattered.
Okay. Is there an easy way to clear the screen?
Yeah.
File me.
Hold down Control-Z. Pretty sweet. All right. So what's the problem with a linked list? Well, you're going to have something that looks like this. You guys should have all coded up linked lists and data structures and be super comfortable with those. They will absolutely ask you to code binary search trees. Sometimes heaps if you study heaps. Sometimes it doesn't really matter. Right? Expect that you're going to have to code some of these. Okay? So we have something that looks like this. What's the real problem? These things are scattered all over memory. We have access to the head of the list, and that's it. We don't have direct access because these things are, there's one way up here, there's one way down here, they're scattered all over memory, and that's why these things are slow. So which one do you want to use?
Array.
Depends. Situation. Yeah, right. It's always an it depends kind of situation. Okay? I'm not going to rehash all of that stuff. You should also generally sort of know the run times of these things in terms of Big O. You guys know Big O?
Yes.
I remember Big O.
And
Believe it or not, computer scientists and gamers and everybody really use this term in daily life. Not daily life, but I mean, to talk to each other, oh, it's a linear data structure, or oh, yeah, it's log-based 2 event. That's the way they really talk. This isn't just theoretical BS. Okay, what's a dictionary?
it's a map. It's a key.
It's Webster, yeah. What does it do?
It's a database.
Did you study this in data structures? Here's the thing. Imagine that I'm trying to map all of you guys into a data structure. Let's say based off of your social security number, something like that. How big would that be? Let's say I used an array to do this. Would that be smart? Why would that not be smart? How many people in here, please don't tell me your social security number. How many people's social security number begins with the number 1? Anybody? 2? There's a 1. There's 2. 9? 8? 7? We got a 7. All right, so we have between 1 and 7, right? What's the problem? How many social security number possibilities are there? How big of an array would I need to allocate to store all these social security numbers? Imagine about 1 billion, right? How many students do I actually have in this class? 60. So do you see the basic problem? So what can I do instead? Huh? Why don't I create... Yeah, we're getting to hash tables. Oh, does it say that?
Yeah.
I was like, oh, great answer. Yeah. So watch what I could do. I could take your social security number and I could mod it by 60. So I could create an array of 60 slots. Yes? Now what does the mod operator do again?
Remainder.
It's the remainder after division, right? So if I mod by 60, what's the range of values I should expect to get back? 0 to 59, okay? So watch why that's cool, because if I have 60 slots inside my array, I take your social security number, I mod it by 60, it maps somewhere into this data structure inside this array. You see how cool that is? So I didn't waste 1 billion spaces. I now have 60, but what's the fly in the ointment?
Two different numbers could be completely different, but have the same.
2 numbers can map to the same slot. So how do we do it? That's called a collision. So how do we deal with that? You can either search for the next available slot, or you could create a linked list coming off of the array. Right? Why is this so important? Because you really do use these kinds of things. When a person has a whole bunch of information that you need to store, you can take some key that they have and then map it into an array. Does everybody get that? You good with that? So everybody knows what a dictionary is. Good. Okay. Others, stacks and queues. Do we have to talk about these? First in, first, yeah, let's skip that thing. And then we get to something that probably very few people have experience with. And this is actually used. Okay, bit packing. We don't work a lot with bits as much as we used to, especially, computer science. We started with bits. Anybody here that's over 40 years old, we have lots of bits, and we work with bits. Okay? So here's my question for you. Let me Control Z on this guy. Are you ready for your math question? Somebody said 2. Very good. In fact, let's do that. A lot of people don't know how to count in binary. So let's talk about that just real quick. What number is that?
That's 3.
If you don't know, it's okay, right? It's 3. It's fine. Let's walk how to do this. It doesn't matter what base it is. It's still going to work, right? This is really the 2 to the 0 spot. This is really the 2 to the 1 spot. And this is really the 2 to the 2 spot. You with me? So what we're going to do, that's a multiplication right there. Right? What's 0 times 2 to the 0? 0. What's 1 times 2 to the 1? 2. What's 1 times 2 squared? What's 4 plus 2 plus 0? 6. Comes out to be 6. With me so far? How do we represent negative numbers? You need to be, I'm serious, they might ask you this. Has anybody had this on a job interview question?
Well, I can imagine how you could do it. You just minus 128 from the...
No, yeah, okay, we're not talking about 128. We're talking about the new 3-bit architecture that's come out from Intel.
You put the ones for zeros and the zeros.
Here, it's really easy. I assume that this guy is negative weight. If it is a signed number, this guy right here can be negative. In fact, it is negative. If you see a 1 right here, it's guaranteed to be negative. So what does this mean? That's a negative 4, if it's a signed number. Now what number do we have? Negative 2. Wax on. Wax on. Okay? So now you know how to represent positive and negative numbers. But sometimes we work in something called hexadecimal. Let me Control Z. Okay? Watch this. So what number is this? 0. Okay, you're still paying attention to the 0. Now what about this? 2. 6. Assuming it's a positive number, let's not worry about sign and everything. 14. Yes? How do we represent 14 with a single character? D, right? So what do? We have 0 through 9. Everybody's good with that. And then after 9 is what? A, B, C, D, E, and then F. In fact, what number is this?
Squiggly lines.
Does anybody know what it is? People go.
1, 2, 3.
I see people rocking back and forth. If it's a signed number. If it's signed.
What's 2 to 11?
This is a really big negative number. Agreed? All of this is a really big positive number.
That's 0.
It's negative 1. If you see a whole bunch of ones all in a row, it's a negative 1. Okay. Now, how does that relate to our lecture today? It doesn't, but you should be able to do that. Okay? Now, let me show you something real quick. How many, let me Control Z here real quick. If somebody says, I want you to convert this number right here, all this ones and zeros and everything, it's a long string of ones and zeros, and I want you to convert it to hexadecimal. And you think, oh crap, what am I going to do? You break it into 4s, right? 1, 2, 3, 4. In fact, let's make this a 0. Look at that. There's 0. Okay. Break this into 4s. Uh-oh, I only have 2 bits here. What do I do? Put some zeros here. Everything's good. Okay. What number do I have in hexadecimal? Here's an F right here. And that's a...
1 plus 16.
C?
11.
Somebody tell me. It is a D? Okay, I'll take your word for it. D. What number is this?
3.
3. There it is. 3DF. You ever seen Windows crash?
Yes.
Blue screen of death. Raise your hand if you've seen a blue screen of death. Good. All right. So what does it say? Classically, it said an error has occurred at OXFF9174. What was that? That was the hexadecimal address of where it crapped out. So there you go. How would I convert 3DF into bits? Do the opposite, right? Okay. Now, how is this used in gaming? Where's the tie-in at all? Let me show you. Okay. I'll Control Z all of this stuff. Watch what we can do. I can use these bits to do something called bit packing. Okay? So imagine that you're creating a game that's an RPG, and have you talked to the old man? Have you acquired the flame of Matthew? Have you... Doom, fine, I don't care. Have you done this? Have you done this? Like, what's the state of the character? Now, how would we save that efficiently? What would you do knowing what you know now? You'd probably have some booleans that are laying around. Right? You say bool and all that kind of stuff. But we can get into bit packing. So what are we saying here? I can say, fine, let's assume that this first one is, the old man. That's right there. Do they have the flaming sword? That right there is it doesn't matter. I don't care. But what we can do is we can use an individual bit to represent the state of the character. With me? The question is, that's all fine and good. How do I determine if they've talked to the old man?
Add another 0.
Add another 0?
Well, yeah, you have to add more numbers for each thing on top of that each track, the longer it's going to be.
Isn't it just a memory
Oh,
address?
he's trying to retrieve it.
Is it a memory address? No, it's just a value, right? It could be a memory address, but in this case, we're going to interpret it as, have they talked to the old man? Clearly, you see, no. How would we do this programmatically? I'd have to use the AND operator. Have you ever seen this?
Yes.
Yeah.
No, probably not.
Oh.
Some of you have not. You've seen the double AND, right? 2 ANDs.
It's data address.
This is a bitwise comparison. So watch the math that we can do. Okay? If I want to check for the old man, right, I'm going to AND these two numbers together. Now what number is this in hexadecimal?
Negative a bunch.
8, 0. 80 in hexadecimal. See how cool that is? We just related to each other as nerds. That was all. Maybe not. Okay. But anyway, watch what I do. I AND it, and the bitwise AND works very similar to how a normal double AND works, right? This and this. What does that give me? 0, 0, 0, 0, 0, 0. See, these zeros are really efficient. And then 0. So what do I know about the old man? I have not yet met the old man. If I see anything other than 0, what do I know? I have met the old man. It doesn't matter even what the value is. You can see that I met the old man just because it's not 0. Now I know what you're saying. This is really stupid. Why would anybody want to do all of this, bitwise kind of stuff? Why is this important? I know everybody's saying, well, mobile, Jeff, clearly all these memory-constrained devices, that's not what we're talking about. What is it? One word. I got you. Networking.
Oh, IP address.
But it's not just the IP address, but think about it. If I'm blasting all of this information, I want to do it in the most efficient way possible, right? So if we bit pack a lot of stuff, it's going to cut way down on the amount of network traffic that we're trying to get as people come and, like these MMORPGs and everything, we're cutting way down on the amount of traffic trying to get the state of the character. Think about it. If you play Borderlands 2 or something like that, how many missions are there in Borderlands 2? How do you know if the other person has completed all of these missions? You're going to send 8, bits per mission, something? No, you're not going to do something like that. So you see, it's an efficiency thing when we're talking about this bit packing. Is it done? Yes, it's absolutely done. Chad, you had a question. No. Any questions about that? You get it? How many people was that new stuff for? A fair number of you. Good. All right. All right, so let's move on. OOP, have you ever heard of this? Yeah, okay. Use objects, use classes, use inheritance, and polymorphism. In this class, if you've always said, this stupid polymorphism they've been preaching, for the computer science folks, listen to me now. If you've never done a game, polymorphism is the way to do it. When you have a lot of different enemies, let me show you something. And my apologies to the gamers. I know I've beat you to death with this. But for the gamers, I have a surprise for you.
New polymorphism.
New polymorphism. No. Okay, so imagine you have an enemy class. Yes? What kinds of enemies could we have? Chihuahua. Yeah, okay. Chihuahua. What else? Cthulhu. Pony. Okay, I don't care. Jeff. That's great. Okay. Everybody's cool with that, right? You've seen UML diagrams a million times, right? So we could say, fine, we're going to have an enemy class, and we're going to have chihuahuas and all these different subclasses, and you know how all that works. Now, why is polymorphism so important here? Because assuming that that is the hierarchy that we have, what I'm going to do is to create a list of enemies. Right? So this could be a chihuahua, this could be a Jeff, this could be a pony. Yeah, thank you. Okay? How would I do this? You would say, no, that's wrong. Undo. No, it's not exactly. I would say a list of enemies called E-list or something like that. That's the best I can do for you. But you get it, right? So what I can do is if I have a generic list of enemies, I can just start shoving all of these ponies and Jeffs and everything else inside that list. And here's the beautiful part, is that I could say something like, you know what, it's notepad time. Okay? So if this is the case, I could say, look, I've got a list of enemies. E-list gets a new, it doesn't have autocomplete in Notepad. New.
You just hit tab.
There we go. So right now, yes, I did hit tab and it didn't work. I have a list of enemies. Everybody is good with this, right? You could add in any number of things. You could say, elist.add a new pony. And you could do that with all the other ones. But here's the coolest part. If I've structured this so that all enemies have an update and they have a draw inside of them, I could then later on inside the main game's update, void update, and I'll just abbreviate here, I could say for each enemy E in the enemy list. Well, yeah, be careful. E.update. There's your polymorphism. This is the most beautiful implementation you could ever see because it doesn't matter if it's a pony or a Jeff or whatever's inside there. I know that it has an update and it has a draw. That's the power of it. And so as E goes through this list, it's going to turn into a pony, and then it's going to turn into a chihuahua, and then it's going to turn into whatever the next thing is, and it's going to update and it's going to draw. Now, how far can we take this? All of your bullets on the screen, all of your enemies, they're all game objects, right? They're all entities, whatever you want to call them. If you create one Uber class, you could derive from it, and you could say, you know what, I have a list of game objects, and then you could just say, I don't care what you are, draw. And it just works. Draw. Yeah, it's like kind of a power trip. Draw, and they all just draw. But it's polymorphism, so it is absolutely essential that you understand that in this class. If you're going to have something reasonable, you can dump everything into one list or a couple lists, but not 500 different lists. All right, and then the last thing here, we get into the part where I'm going to surprise the gamers. What are two things in 1302 that I beat you to death with?
Polymorphism and inheritance.
Inheritance and polymorphism. Why? Because they are always in job interviews, right? And I said, oh, well, you always want to have this good hierarchy. I lied. You don't find out until you're a senior, but I've been lying to you for quite some time. Because I keep saying inheritance is going to be there, polymorphism is there. In gaming, that may or may not be true. The example that they have in the book is imagine that you have this RPG, and you have characters that can talk, right? And then you have characters that don't talk. So you can imagine the hierarchy that we would create. You'd have, thing, game object, or something like that, and then you'd have talkable things over here. You'd have non-talkable things over here. Well, what happens if all of a sudden you imbue a sword and the sword can then talk? What's that going to look like? Watch this situation.
Make the sword a subclass of talking.
But what if somebody said make the sword a subclass of talking?
Yeah, talking.
Watch what this is going to do, right? Let me show you this. Let's say that there is a thing class. With me? Or you could call it a creature or whatever. We have a wolf, and we have a man. And what can I create now? I can create Wolfman. Everybody's like, that's really cool. But let me show you the problem. How does a wolf, I don't know, eat? This thing is really screwed. Is the pen the only thing that works?
Yes.
Okay. Okay, so we have eat. Uh-oh, can I? No, I'm making a mess with it. We have eat there and we have eat here. Everybody with me? How does a wolf eat? It does whatever wolves do. I don't even care. How does a man eat? Totally different, right? When I say eat,
Which one is it going to call?
which one does it call?
That's when the
Okay.
Error.
So this is why so many languages do not allow multiple inheritance. You cannot inherit from two classes. What can you do instead? Something called an interface, which is kind of like a class, but it is just a whole bunch of methods that you're going to inherit. Okay? This thing right here is called the diamond of death. Right? So if you ever hear of something called the diamond of death, it looks like this. It should bring this image to mind.
So you could technically fix it if you specified it in every single class.
You could. Right? So how are we going to solve this talking sword problem? We use component-based architecture. And this will be the last thing that I talk about, okay? So wouldn't it be cool if I had this generic, just blank slate object, and then I could start adding components to it? Like, you know what? You're now renderable. People can see you. You know what? Now you're an audio source. You know what? Now you're a physics object. Now you're this. And I keep adding things to that object. Has anybody seen that before?
Yes.
Where? Unity. That is genius, right? Because now all I have to do is start adding, oh, your talkable thing, I'm going to add a talking component to you. And so if the code would look kind of like this, if we had this game entity sword that's a new game entity, whatever that thing is, I can add a component that's a damage component, a render component, a talking component, and so on. And then when I say update, what it'll do is it'll tell all of the components that are inside that sword to update. It's pretty slick when you think about it.
Whoa.
Yeah, I know, I lied. People are really disappointed in me now, but
How can we take out?
and I know what people are saying now. How do I know you're not lying to me now? I'm not. No, that's the truth. Okay, so what fears do you have at this point? Because I'm about to let you go.
Wolfman.
When is the assignment due?
Tomorrow.
Technically, it's due at midnight. If you're one of those late night owl folks, well, late, was that right? Late night owl. Thank you. And you want to turn it in at 4 o'clock in the morning, fine. D2L is open until 8 a.m. If you turn it in at 8:01,
Too bad.
too bad. Is everybody with me?
Yeah.
Get it turned in early. Yes, sir.
So wait, where is the Dropbox again in D2L? Because I already did it. I went
You have to
online and
submit
saw
it.
we had this.
Yeah, so when you log into D2L, I hate to say it, there should be a Dropbox icon there.
Yes. We have to go into the class.
Yeah, it's okay. It's at the top. Dropbox, you should click on it, and you'll see a list of assignments. This is assignment 1. It should say particle system or something there. Click on that, and you should be able to upload that.
Do we need to like rename the project we use here?
No, but let me say something real quick. When you submit your assignment, there are some things that you can eliminate from your project.
The bin and all.
The bin directory and the OBJ directory, and there are 2 sets of those inside your project. What are you supposed to do? Please listen to me. Don't use RAR and 7-zip and FunkZip and all these weird kind of zips. I have like WinZip and I think the standard Windows zip or something like that. All you have to do is right-click on the project and say send to compress. It's on all Windows machines. You don't have to have a special funky zip thing, because then that means I have to install 18 different versions of funky zip on my machine. Okay? It's not hard. Right-click on the project, the highest level. Right-click, send to compressed, and you get a zip file, and then send that to D2L. Also, if you could, because some of you really do funky things with your code, take a snapshot of it. I know some people were having difficulties with full screen. Don't just run it in window mode, or say full screen is no.
It's in, you go into the or it's in the, for the first method, and it says, is game full screen?
Yeah, I think it's this dot is full screen gets true, makes it go full screen. Be careful, if you do that, what's going to happen? There's no X. There's no X. You have to code that in. You'll find that out. So listen, make sure before you say is full screen is true, that you check the key to see if the escape key is pressed, and if so, exit out of the application. Yes, sir.
Yeah, it already set up.
It does,
Yeah. You gave us to work on. Yeah. It's already set up.
but the escape key is?
Yes.
Okay, never mind. We're good. So it's 5:39. Any last questions before we take off? All right, I'll see you Wednesday.
You said to see you if the grades were missing from D2L?
Yes. Or do this. Send me an email, right? Because I know that you have a grade. I know for a fact you had a grade. I graded it this morning.
Okay.
So it's there.
I'm just not seeing it.